All right, it's BMS day today. We finally getting around to doing the BMS. So we've wired in the last two wires to our battery, which were the main positive and negative leads. So we've got those. We have the battery main now going to the shunt, and we have the other positive one going to a Class T 400 amp fuse. So we'll take voltages and everything to make sure everything is okay, and then we'll fire up the BMS. We'll also discuss a little bit about what this BMS does and how it interfaces with the rest of our components. We have a Victron inverter, charge controller, plus a Color Control GX. So we'll talk a little bit about that and why we chose this particular BMS. So anyway, we'll get going and we'll start checking all the voltages. All right, so our first measurements are going to be across our mains. So our main comes through this fuse, so if we touch right here, we should see 55.6 volts. Again, at the front of our contactor, we should see 55.6 volts. I don't know why I'm crossing my arms. And on this one, we shouldn't see anything because this contactor works as a giant on and off switch for the BMS to turn power off if it finds that there are problems. So now these wires go to each of the cells. So if we go to ground and then we go to the power wire, we should also see 55.6 volts. We do. And so now across cell 1, 3.97, cell 2, 3.97, cell 3, 3.97, cell 4, 3.97, cell 5, 3.97, cell 6, 3.97, 7, 3.95, 8, 3.95, 9, 3.97, 10, 3.97, 11, 3.97, 12, 3.97, 13, 3.97, and finally cell 14, 3.97. So, all right, so we've got the proper voltages coming in. So I feel safe to turn this on. Actually, to be perfectly honest, I've already turned it on and already had problems, but that's the procedure you would use just to check to make sure that everything is okay before you go firing anything up. We actually had some issues yesterday and we contacted REC and we were like, man, we can't get this thing to fire up or connect or anything, and they literally responded within like 2 hours. This happened to be late yesterday because they are in a small country. What was it?
Slovenia.
So they're in, let me wait for that to pass. So we contacted them yesterday, and it was very late at night here. I think it was like 11 o'clock or something. And I made a video of exactly what was happening, and I uploaded it to YouTube, then sent them the link and said, hey, any advice you could give us for troubleshooting this, we'd greatly appreciate it. And he literally came back within like 2 hours and had a new firmware for us, as well as like, okay, here's why it's not working. So anyway, so their customer service has been awesome. We've had a great experience with them. Every question we've asked, they've always come back within a day, and they're literally on the other side of the world. Anyway, so we would check all these BMS wires. They're all within spec. Our power is on. We're getting power to our contactor, and then we're getting power to the other side of our shunt. So if you're not familiar with a shunt, the reason we use a shunt, especially on the lithium system, is it actually counts the amperage as it goes actually in either direction. And so if the battery is getting charged, it will show a positive accumulation. If the battery is getting depleted, it'll show amps coming off of the battery. And the reason that's so important with the lithium system is because a lithium system tends to have a very constant voltage. Unlike a 12 volt lead acid system, which more or less kind of declines linearly. So you can literally use the voltage to estimate what percent of the battery you've used, what the state of charge is. On a lithium, the graph goes more like this, and then it flattens out for a long time, and then it falls off extremely rapidly. So just by knowing the voltage, you have really no idea what the state of charge is. You don't know if you have 70% capacity or 30% capacity, because the voltages are so close. So anyway, that is the reason a shunt, especially on a lithium system, is pretty much essential to knowing your state of charge. So that's one of the major components, is this shunt. The other one is this contactor. As I discussed before, it works as a big on-off switch. If something were to happen and the BMS says, oh, there's a danger of the battery being harmed, it will shut that off, and all power to anything will be shut off. And what that really means is then the battery won't go into a state where it's overcharged or undercharged. So the purpose of a BMS is, the BMS first of all stands for Battery Management System. What its purpose is to monitor the battery and to be sure that it remains within its specifications. That includes voltages. So for lithium batteries, everyone's heard of all these lithium fires and cell phones catching on fire and things like that. That's what happens if lithium batteries either get overcharged, meaning they're over 4.2 volts, there's too much voltage in the battery, or if they're undercharged, if they get under 3.2 volts, there's a danger that it could damage the cells. So this ensures that if it ever gets outside of those parameters, it shuts everything off and sounds an alarm. So it does that through the contactor. So everything runs through the contactor. So the other piece of thing it does is it monitors cell temperatures. So there are 3 temperature probes in those batteries that are telling this BMS what the temperature of the battery is. It also has an internal temperature monitor because this particular BMS also does cell balancing, which means while you're charging the battery, if one of the cells happens to get to a higher state than the other ones, then it will throw a resistance across that cell to bring that cell down a little bit while the others charge. And so in theory, it should keep them at about the same level. At least that's the way it's supposed to work. The other function that it does, and this is one of the major reasons that we chose this one, is because this particular BMS interfaces with our Victron stuff natively. So there's a cable that it comes with, and it's basically an RJ45 connector, but it will talk to the VE. So Victron's proprietary bus is called the VE bus, and it talks VE bus natively. So it will tell the Victron controls and everything what the state of charge of the battery is, and when to turn off the charge controller, or when to turn off the main charger and things like that. So that is one of the main reasons that we went with this one, is because it speaks Victron natively. We have firmware now that we've gotten that will enable it to the newest Color Control GX firmware, so it'll enable it to the newest. And if you don't know about the Color Control GX, it's a pretty neat thing. It displays where all the power is coming from and where you're drawing power and things like that, as well as it uploads it to this portal where you can see all this stuff remotely. So anywhere in the world, you can see what your batteries are doing. So anyway, the other piece of equipment here that we have is this pre-charge controller. So the purpose of that is, and I didn't know about this before I started, but I guess pre-charge controllers are actually kind of a common thing, is what happens is there's a lot of power coming in from the battery. And so what the pre-charge controller does is, for the first, I think it's 7 seconds, what it'll do is it'll put a small trickle charge into the components that you're powering, and that will, what that does is it serves to like get the components, so capacitors and things like that, it charges them up. And so when there's what happens is when the power is turned on, there's a thing called an inrush of current, and what that does is really hard on electrical components because it's basically a big current slamming into those components. So the theory is when you pre-charge them, it kind of gets all that stuff charged up and ready, so when that inrush comes in, it's ready to accept that. It's supposed to prolong the life of your inverters and charge controllers and things like that. So we have that hooked up. We have it hooked up. So what happens is there's a delay. So this will turn on, and then it'll start trickle charging, and then 7 seconds later it'll turn, or whatever seconds later it'll turn this main contactor on, and you can hear it click, and then it'll send power through the system. So that's kind of a brief overview of our BMS. We're gonna get to setting it up right now. All right, so we're about to fire this up. So we have our computer. We bought the software that will talk to the BMS. I think it was like 50 bucks or something, but it will basically, it came with the cable, which is a little DB9 cable, and on the other end is a little USB cable. And basically it talks to the BMS and tries to establish communication and stuff like that. So we'll go ahead and plug this guy in. And then we will bring up, it's called BEC Master Control. So we'll bring that up, and you'll have to excuse, it's a little bit ugly because I'm using an old version of Windows. I'm not really a Windows user. The last time I used Windows, I had bought Windows 7, so I wasn't going to rebuy Windows to do this stuff, so I just used Windows 7, so that's what we're using right now. So anyway, I'll fire up the BMS, and you'll see the green light come on, and then the red light, and then the green light, so it will go back and forth. It's kind of testing itself right now, and it will come in here, and it will start. Oh, there we heard our contactor. So that was our contactor going off, and now everything is in the green. So now we'll just see a heartbeat of a light here. It does a thing where it starts up and it starts testing. So it internally tests itself just to be sure that A, its software is correct, and B, that all the cell things are correct and that impedances are correct and things like that. And then it comes up and is live. So, but the then it will start displaying here. So here we see our voltages. So here's cell 1 is 3.975, cell 2 is 3.978, 3.978, all the way on down to cell 14. So they're pretty close to what we got with our standalone multimeter. This actually measures out to the 1,000th. Ours only measures up to the 100th. So we also have cell resistance. So this was what I was talking about that they use to determine the state of health. So also here we see our highest and lowest cells, as well as the voltage of the whole pack. So we also see temperatures. So here's the temperature of our cells and the state of charge, which is how much battery we have left or how much it thinks. So one thing I read on this is the first time you fire it up is it will always start at 50% regardless of how it's set, and then when you charge the battery up it'll go to 100 and then it'll start doing the real thing. So this is now running. It says it's locked because we have to enter a password here. And this worked last night. We couldn't get this to work the other day. There it goes. Yeah, that works. So now it's unlocked and it's present. So it'll keep taking readings. We can also do like a log file from here. So we can start a log file, and then every 4 seconds or whatever, it'll put down what all the parameters were. So it'll kind of give you a running log file of how your battery is doing over time. So this, I think this temperature here is the internal temperature of the unit, and then these 3 temperatures are the temperatures in the battery. So I could be wrong about that, but I think that's how it works. There's also a tool in here that allows us to flash So it allows us to flash new firmware. We've had to use that because they sent us new firmware. And there's also the settings for this thing. So right now it's going to 4.15 volts, and we'll probably bring that down to something like 4.1 volts or something, just to keep it not all the way up to its full state of charge. So the last piece of equipment that we haven't mentioned yet is this little screen. So one of the cool things about this particular unit is that it has this little monitor which essentially displays most of this information in just a nice little screen that we can just mount up on the wall. So it'll have all the individual cell temperatures, voltages, all that stuff, the state of charge, the state of health, all that stuff will be on this little screen. It's a little touch screen, and there's little menus and things like that that you can show all the different various screens. So that was one of the kind of a cool feature of this battery system. Of course, it'll also show like state of charge and stuff like that on our Victron screen, but this just kind of shows us at the cell level what kind of activity is going on. So we thought that was a pretty neat feature. All right, so the last little piece is the little screen we talked about, and this will go inside, probably next to our color control, and it shows the state of charge, the battery voltage, what kind of current we're pulling off the battery itself, the max cell, so this is 3.978 is the highest cell, the lowest cell is 3.957, the temperature, the time to empty, so this will try to calculate based on our current load how much time we have on the battery. So there, if we click this button, there's also each of the cell voltages, so it shows each voltage on each cell, as well as the impedance on each cell. This one shows the temperature, so these are the three battery temperature probes. And then this one here is the temperature probe for the actual unit itself. Like I said before, it uses a resistor, and then these are options, so you can like rotate the screen if you want it to be this way versus straight up and down. Anyway, this thing uses internal resistors to keep the battery balanced, so it monitors itself as well to make sure it doesn't overheat. So it looks like everything is working. If we measure across, so the one last thing was we need to make sure that we're actually getting voltage out to the system now. So the other side of the contactor should now show that it has full voltage. So it should show 55 volts. So if we come to here and we come across here, we'll see 55.6 volts. So if there's a problem, the BMS will use this as an on-off switch to turn things off. So it looks like it's working. All right, so that kind of wraps up our BMS video. We're pretty satisfied that it's working and operational and doing exactly what it's supposed to be doing. So next steps are going to be to hook it up to the Victron, hook up to the inverter as well as the color control. Once we get those all talking and everything seems to be fine with that, we'll go ahead and plug it into shore power and then start to get our first full charge on the battery and see how that goes. We'll monitor that real close to make sure that things are within parameters and things aren't overcharging and stuff like that. So then we'll actually run a load. So we'll turn the air conditioner on or turn the heater on or plug something in and run a load and see how it all handles it and see what kind of run times we can get. Per our calculations, we should get about 9 to 11 hours of running our AC. So we may have to put a bigger load than that on the system if we want to bring it down significantly. But anyway, we're gonna wrap this one up. This is our BMS. We'll post links to our BMS research, what we did, why we chose this one. We had a couple BMSs that we were considering. So we were considering another one by a company called Orion BMS, and this one. So we we went with these guys because they were really enthusiastic about answering our questions and getting back with us, and they're pretty large in the boat and yachting community, so they seem to be pretty well established with that group of people. So anyway, we're pretty happy with it. It looks like it's doing exactly what it's supposed to do. We're going to go ahead and try to start the next phase of it now.